Oh, okay, so this one I think you only get a couple chances for, so, number 10, chapter 4, homework, number 9. Your least squares regression line always goes through the point x bar, comma, y bar, and that's always going to be true. So it'll go through your average for the x, comma, your average for the y. And that's just because of the way the formula is set up. But the formula, we don't use the formula, we use the program and the calculator. But the formula is set up using these two, and then using your slope and your y-intercept. So your x bar and your y bar are always going to be a point that's on that line. So that one's always going to be true. Number 14, it says explain what each point on the least squares regression line represents. So if we're looking at points, just our points on the scatter plot, those are going to be actual observed values that we saw from our raw data values. But this one, they're saying the point on the least squares regression line. Remember, our least squares regression line is used to predict what we think the y value is going to be. So here for the answer, it says the predicted y value at the corresponding value of x is not going to be necessarily ideal, and it's not one of the points in the data set. That's going to be the points on your scatter plot. Represent the y value of the data set at that corresponding. I don't understand. Okay. D, I think, is similar to C. That's weird how they worded it. But, so I'll go ahead and write it down. Number 14. If you have a point on the least squares regression line, that's going to be the predicted y value at the corresponding x. So I don't understand what they're trying to say with D. It's kind of worded funny. But that's the one you'll want to select for that one. Oh, here's where I was saying for the least squares, here, let me do this one. Okay, so the least squares regression line explains this amount. Oh, this one's not too bad. You actually don't have to put this one in your calculator because they say the coefficient of determination is 90.6, so that's going to be the number down here. You don't even need to move the decimal. So it's going to be 90.6 because that's going to be how much of the variation is explained. But whenever we talk about variation, we want it to be the y value. So y value is the length, so we'll look at the length of eruption for that one. It's always the y value, not the x. So that one you didn't even have to calculate, you just have to put that percentage in. Okay, so last one, number 17, this is the one with influential points, so we'll go ahead and talk about this one. They give us the equation of the line, and then they added another car that is this many pounds and has this many miles per gallon, and then they're going to figure out the coefficient of determination for our new data set, right? Mm-hmm. And they ask us if it's influential. So here's our data set. We have to find the coefficient of determination. We'll do that by putting it in our calculator. Let's do that real quick. Let's see. Okay, these are so long. Okay. Your numbers will be a little bit different. Okay. my usual, but now I have another one. I'm adding a 12th card that's 3, 4, 2, 5, and 13. Okay, so now everything's the same length, and I'm going to find my new coefficient of determination, so I'll go to Stat, Calc, Linear Regression, to get my R squared, which is 0.524. Okay. They want me to write it as a percent, so I'll go ahead and move the decimal over to 52.4. So right here, my R squared, I'll move the decimal over here, and I get 52.4. Okay. And then it asks us how the 12th car affects the data set. So they don't tell us R squared, do they? They don't. Okay. All right. Well. So number 17, R squared 4. They don't give that to us, and now we've got R squared after, just calculated was 52.4%. Right? All right. So we got to figure out what R squared was before. So I'm going to come in here to my lists, and I'm going to just go down and delete that one out. So I'm going to come up here, don't retype it, just highlight it and push delete. And come over here and push delete. And so now if I do Stat, Calc, Linear Regression, I get my R squared is 79.5. So for these ones, I'd say if your R squared changes maybe like 10% or more, then it has a significant impact on it then. If it's something more like 2% or 5%, then maybe it's not that big of a deal. But in this case, it went from 79.5 down to 52.4, so it decreased it. So for my last one, since it did increase it by quite a bit, it went down by like what, 17%, which is a lot. Like I said, more than 10%. So I would say that yes, it is influential because it changes it. And is it an outlier? So I've got 3, 4, 2, 5. 3, 4, 2, 5. 3, 4, 2, 5. So it kind of fits in with my other ones. So if I graphed it out, 3, 4, 2, 5 would kind of be in with the other ones. So for this one, the last part is part B. Yeah. I'll say it's influential because R squared decreases. And then as far as if it's an outlier, I would say no, because the X value is
Wouldn't it be an outlier though, since 13 miles per hour is significantly lower than everything else?
with the outliers, I think they're only looking at the X values. I'm sorry, yeah, the X values and not necessarily the Y values, I think. Because I kept getting it wrong when I first started doing this, but I didn't know why. So
I did too, but I thought I was
yeah.
getting it wrong because the opposite, because I thought it was
Yeah,
the X.
it's in the same interval as the other X values. So if you graph what this looks like here, so let me get this down. So let me make sure. No, it's not an outlier. Oops, so that's wrong. Maybe yes, it is an outlier. Correct answer is it's not influential.
Influential, but it is.
Well, let me look at it some more. We can talk about it on Wednesday.